Hello guys, welcome to my channel Brain Tech.
Today, we are going to do a topic related to complex numbers. It is a subtype of that. I guess everyone have heard the name of De-Movires theorem. So it is a part of that. Is expansion of sine of n theta cos of n theta in terms of powers of sine theta cos theta. So this is a topic that we will be expanding sin n theta cos n theta in terms of powers of sin theta and cos theta. For this topic, some basic things you should know about it. First is z is equals to cos theta plus I sin theta, where everyone knows that cos theta is real part and sin theta is imaginary part. Second step, we know that I square is equals to minus 1 in complex numbers. Third step, you should know about De-Movires theorem. De De-Movires theorem that cos theta plus I sin theta the whole raised to n is cos of n theta plus I sin n theta. Whatever will be the power of n will be replaced here. Next comes binomial theorem. I'll give you a short trick to remember binomial theorem when we'll be solving the sums, which is nc0 cos theta raised to n plus nc1 cos theta n minus 1 I sin theta plus nc2 cos theta n minus 2 I sin theta the whole square plus so on. So few might remember and few might not remember. So if you don't want to remember, I'll give you a short trick while solving the sums. These are the basic steps you should know for this topic, that is expansion of sine of n theta and cos of n theta in powers of sine and cos. So the next important step is the Pascal triangle. So we'll see that to make a Pascal triangle. Many of you might be knowing, those who don't know, so take a note of it. I'll write it here. So while solving sum, it will be used for us. Uh, Pascal triangle. In Pascal triangle, write here 1, 1, 1. Then 1 plus 1 is 2. 2 plus 1, 3. 2 plus 1, 3. 1. 3 plus 1, 4. 3 plus 3, 6. 3 plus 1, 4. 1. 5. 10. 10. 5. 1. Now, how to use this Pascal triangle? I'll just let you know why I have wrote this. You'll understand while taking the example. So let us start with an example. Express sine phi theta cos phi theta in terms of powers of sine theta and cos theta. So by looking at the sum, you need the value of sine phi theta and cos phi theta in terms of powers of sine theta and cos theta. So let us start with the solution. Our first step, always remember, we will write De-Movires theorem. De-Movires theorem. Here we'll see the value of n. Here n is phi. So we'll write cos theta plus I sin theta the whole raised to phi is equals to cos of phi theta plus I sin phi theta. So this is De-Movires theorem. Second is, we'll write binomial theorem. Now this is one of the most important step where you'll get your answers. I'll give you a short trick. So watch this video from start to end. Do not miss anything in middle, because if you miss anything, you won't understand the sum. So in binomial theorem, we'll write cos theta plus I sin theta the whole raised to 5 is equals to. Now we have to expand it. Now while expansion, I'll give you 3 steps. If you follow these 3 steps, you'll get your answers. First step is, always the cost component, that is the real part, will go on decreasing from start to end, and imaginary part will go on increasing. Now how? First step is, I'll write the real part, that is decreasing. That is, I'll write it down. Cos raised to phi theta plus, you'll write cos raised to 4 theta, it is decreasing, plus cos cube theta plus cos square theta plus cos theta. Okay, this we have written in step 1, cost part, real part. Now we'll write the imaginary part. In imaginary part, leave the first, from second space we'll write imaginary part. I sin theta, it will go on increasing. I sin theta the whole square. I sin theta the whole cube. I sin theta the whole raised to 4 plus, your cos power also will be 5 and sin power also will be 5, and then we'll stop. This was the second step of sin. Now third is, we'll put the numbers. Now this numbers, how to put it? So for that we'll see the Pascal triangle. This will be for n equals to 1, n equals to 2, n equals to 3, n equals to 4, n equals to 5. My here n value is 5, so I'll see this 1, 5, 10, 10, 5, 1. So I'll just put my numbers. That is 1, next is 5, next is 10, next is 5, next is 1. So this was a trick that you don't have to remember. Binomial's theorem formula. Simple 3 steps you follow, you can solve any sums related to expansion of powers in terms of cos and sin. So afterwards, I hope you would have understood this. So we rub the above part. Now you have to get the value of cos of phi theta. Cos phi theta means all the real part, all the real values you should get it. When you look here, when you look here, first value is a real value, so that will come into cos part, that is cos raised to phi theta. When you write the value, just write it out. Then the second value, I part is coming, so that is imaginary value. Here we'll see 10 cos cube theta, I square sin square theta. I square is -1, so this again becomes a real part, so we'll come here. I square is -1, so plus and minus is minus, which is 10 cos cube theta sin square theta. This will cut it. Here we'll see whether it is coming in real part or imaginary part. Here it is I cube. First you check for this only. I cube. I cube means what? I square into I. Here I square is -1. -1 into I is again here. This comes into imaginary part. I raised to 4 means what? I square into I square, minus into minus plus. So this will come into real part. We'll strike it out. We'll write here minus phi cos theta. No, sorry. Here it will be plus and sin raised to 4 theta. And here I raised to 5 means I square into I square into I. So that comes into imaginary part. So this is the value for cos of phi theta. This is the final answer for cos phi theta. Now we'll solve for sin of phi theta. Sin of phi theta is very simple. Don't write the I part while writing for sin phi theta, because this already it is an imaginary part. Both I cancels on each side. So we'll write it. Here it is phi cos raised to 4 theta sin theta. We'll strike it out. Then next come I square, that is minus 10 cos square theta sin cube theta. We'll strike it out. Here comes I square into I square into I. So which is minus minus plus. So it is plus sin raised to phi theta. So this is the solution, and this is the value for cos of phi theta and sin of phi theta in terms of powers of cos theta and sin theta. I'll give you one sum for practice. Let me know the answer in the comment section. The question is, express sin of 4 theta cos 4 theta in terms of powers of cos theta and sin theta. I hope you have enjoyed the video. If you have really understood the steps, kindly share, like and subscribe my channel for future updates. Thank you.